Yes, student. Now I have defined you another question of inverse of Laplace transformation. Okay. Here you find solution from the convolution theorem. Yes, this theorem. Using this convolution theorem, the example is this one. Use convolution theorem to find Laplace inverse s plus 1 whole square. Yes, this one. Now, therefore, let us suppose that this can be done as Laplace of, yes, here we can suppose solution of this one. Here you are using convolution theorem. Yes, let Fs is equal to 1 by s plus 1 whole square and Gs is equal to 1 by s square, so that Fs into Gs is equal to 1 by s is s plus 1 whole square and this into s square. This is the question. Here you are using convolution theorem. So the Laplace inverse of, yes, Laplace inverse of Gs, this is equal to, Laplace of Gs, yes. So Laplace inverse of 1 by s square, that is Laplace inverse of 1 by s square, yes. This is equal to, t, yes. Everyone, all of you know Laplace inverse of 1 by t. And Laplace inverse Fs, so you can find out, which is given as Laplace inverse 1 by s plus 1, yes, whole square, and here you are using 1 by s whole square, so this can be again written as s, this is equal to Laplace inverse, yes, this can be written as minus of d by ds of 1 by s plus 1, yes, and this is again is equal to minus of Laplace inverse d by ds of 1 by s plus 1. Okay, so this is again is equal to d by ds of this, and so Laplace inverse of this can be written as, by the derivative property, this is equal to, this is equal to minus t, first derivation is here, minus t Laplace inverse 1 by s plus 1. Earlier question I have defined these types of property. Okay, so there is no confusion. Okay, now, so this is equal to plus t, okay, e to the power, yes, e to the power minus t, e to the power minus t, and Laplace inverse 1 by s, so this can be written as t e to the power minus t, and here which is 1, so e to the power minus t. Or you using the different type of property, directly you can define this one, that is Laplace of inverse of 1 by 1 plus s square. You can also define the other types of this evaluation of this one. Okay, yes, so from this derivative definition I have defined this one is equal to this one. Then here you see that you know the value of Laplace inverse GS, you know the value of Laplace inverse of Fs. Now you operating the convolution theorem. I think last time I have defined the convolution proof of the convolution theorem. Thus, yes, by convolution theorem, yes, we have Laplace inverse, yes, Laplace inverse Fs Gs, you know the Laplace convolution theorem. This is equal to Laplace inverse, here is in your question, this is 1 by s plus 1 whole square, s square, yes. So the this is equal to 0 to t according to the convolution theorem, u e to the power minus u and t minus u du. Yes, here the first term, here you see Fs. Fs is this one, yes. Fs and Gs is this one, yes. And according to the property, you know that f of this one, f of t and f of g minus u, like that. Okay, you know the property. So the term, this one is this one, or this one is this one. Yes, okay. You know the convolution theorem, property of this convolution theorem is this one, so you can write down this one. Now from this property, actually this one I have defined here, you have defined here the Laplace inverse of GFS, yes, you say that within bracket we have defined here is Fs and Gs, yes. This is equal to, according to this one is convolution theorem, this is equal to, you know, 0 to t, yes, f of u and g t minus u du. Okay, you have remembered this one. Okay, I think you have no any problem. This one is this term and next one is this term, yes, f of u and gt minus 1. Okay, now you have been converted in the convolution theorem. Now you can integrating this and now you can solve this. Okay, then again this is equal to, yes, this is the convolution theorem, so this is only for your knowledge. Okay, and now the question is, it is sufficient if you write down the by convolution theorem this and again this one, this. Okay, here is the integral from 0 to t and t minus u, therefore this can be written as minus of integrating this, therefore you get minus of, yes, ut minus u square e to the power minus u, and again because here is ut and u square, substituting this minus of taking the integral of this one, so this become this one 0 to t, yes. And now here another this one, this is plus, yes, and 0 to t and t minus, differentiation of this is 2u and e to the power minus u du. Okay, and this is equal to, evaluating this is 0, evaluating this you get the value, actually you can integrate this, and now you get the value is t e to the power minus t plus t plus t e to the power minus t plus t plus 2 times e to the power minus t plus minus 2. Integrating this, now you can get. Yes. If you want to multiply this, then you also integrating this. And now you get the result is like that. Okay. You can solve this integral, now you get the result. Okay. This is a question for the convolution theorem. So many questions you can solve by this one. Here is only you apply this one. F of s and gs. F of s and gs is equal to this one. Then you get the f of s and gs, and now you can apply and solve. Okay. I have also defined you another question of convolution theorem like that. Yes. The other question is convolution theorem. Let us solve this. This is again you can solve. Next part is you can see second part. Laplace inverse 1 by s square plus 4, and here is also s plus 2. I think this question you can also apply in the same method. Yes, as the earlier problem, similarly you have obtained according to here is also first one is suppose. Yes. Yes, I think you have cleared this convolution theorem, all the questions. That let fs is equal to 1 by s square plus 4. Yes, and gs is equal to 1 by s plus 2. Okay, Laplace inverse on both. Yes, Laplace inverse of fs which is equal to Laplace inverse of 1 by s square plus 4. Okay, and here is again Laplace inverse gs. Yes, this is again Laplace inverse 1 by s plus 2. And you know all these values. Laplace inverse of this one. Laplace inverse of fs you get. Laplace inverse fs. Yes, this one you get. This is equal to, yes, sine of 1 by 2 sine, yes, 2t. And also here you know Laplace inverse gs you again get. This one is, you know, e to the power minus 2t. Okay, you get all these terms. Okay, now you apply another first part. Similarly you can operate and then you can solve the next part is again. Next part, here you see that Laplace by using, yes, by using convolution theorem. Yes, we have Laplace inverse fs gs which is equal to Laplace inverse 1 by s square plus 4 and again 1 by s plus 2. So as the earlier part, first part you have defined in the integral form, that is 0 to t. Yes, and here is you also show that here is f of u g t minus u. Yes, so here is also this become e to the power 1 by 2. Yes, 1 by 2 sine 2u and e to the power minus 2 g t minus u. So here is t minus u. Okay. Now integrating this, therefore this become 1 by 2 e to the power minus 2t. Yes, e to the power minus 2t, and the integral is 0 to t sine e to the power 2u. Yes, again sine 2u here, and also become e to the power 2u. Yes, 2u du. Now you remember the integral of a to b is e to the power ax sine bx. Yes, you know this result, or you can operate by reduction method. Okay, earlier I have defined this property in another example. Okay, so this integrating this, you become 1 by 2 e to the power minus 2t here is, and here become e to the power 2u and 2 sine 2u minus 2 cos 2u. You know this property, this you can know in the formula form, you can also know. Yes, e to the power integral of this one, integral e to the power ax sine bx dx, you know, integral of this one, you know, from any limit. Yes, and earlier example, you know this one. This is equal to this divided by this. Yes, divided by 8 e to the power 2u. Yes, e to the power ax b sine bx minus 2 cos bx, that is this one. Yes, and the limit from 0 to t. So you are operating this limit, and now you get the result is 1 by 8, yes, sine 2t minus cos 2t plus e to the power minus 2t. Yes. Okay. Therefore, f of inverse of this one, that is, you say that Laplace inverse according to your question 1 by s plus s square plus 4 and s plus 2. Yes, this is equal to 1 by 8. Yes, sine of 2t. Okay, minus cos 2t plus e to the power minus 2t. Yes, clear? Okay. Thank you. Next video I also defined some other questions of inverse.